Okay, completed. Is it complete? Okay. Look here. I'm trying to derive an expression for drift velocity. Let's see. Expression for drift velocity. How we can derive an expression for drift velocity? Can we try? Okay. I'm drawing the same figure here. I'm drawing the same figure here. This is our same figure. I'm applying a voltage here. Here is a positive voltage and a negative voltage. And if we have applied a voltage like this, the electrons will move like this, right? Electrons will move in this direction. The same figure. I'm using the same figure to derive it. Right? When an external voltage is applied, there will be a force on these electrons, right? There will be a force acting on these electrons. And I'm starting with this idea. If there is no external field, if there is no field, if there is no field, what will be average velocity? What will be average velocity? You can term it as U average. What will be average velocity if there is no external field? That will be 0. Right? Huh? If an external field is applied, there will be a force acting on these electrons. Right? Can I write that? Huh? If a field is applied, there will be a force acting on the electrons, right? If a field is applied, there will be a force acting on the electrons. A force acting on the electrons. Acting on the electrons. Right? I will give you the time to write it. Okay. And what will be that force? What is that force acting on that electron? Yeah, electrostatic force. You have electric field here and a charge here. What is this charge? This charge is charge on an electron, right? And I have told you that there will be a force acting on this electron, right? Then what will be that force acting on the electron? Right? What will be the force acting on the electron? What will be the force acting on the electron? Can you give me the equation for that force acting on the electron? You don't have you don't have to go to 1 by 4 pi epsilon naught to if I have given you this equation, this parameters. That's it. If I have given you these parameters, the Moore's equation is simply Q into E, right? Charge into electric field. Also, we have another equation for force. What is the next equation for force? The general equation of force. What is the general equation of force? That's ma. Got it? That's ma. Ma is the general equation of force. This is the force acting on electron, right? We have that. But we also know that F is equal to ma. So you can equate them. That means ma will be equal to what? QE. No. What is QE actually? What is QE actually? QE is charge into electric field, right? Charge into electric field, right? What is the charge on an electron? Charge on an electron. Charge on an electron, you can take it as minus E, right? That's minus E. Charge on an electron is minus E. So this F will be minus E. Minus E. You can take it as equation number 1 or without any number. No problem. Just 2 equations. So Ma will be equal to minus EE. Ma will be equal to minus EE. Now you can have the equation for A. What is this A? Acceleration. What is A? A is acceleration. What is the equation of A from this equation? A is equal to minus EE by M. This is equation for acceleration. What does it mean? acceleration of electrons. If electrons get an acceleration, they will also have a velocity. We need this velocity. We need to find this velocity. The average velocity, otherwise, is called drift velocity. So you need to find this average velocity. That's why we need A here. Because in the equation of velocity, there is acceleration in it. Which is the equation? This equation, B is equal to U plus AT. So you need A. Right? You need A. You have already U. What is U? U is what? Initial velocity. A is what? Acceleration. T is what? Time. Time for which this electron takes to increase this velocity. Now you can see an acceleration here. That means the velocity has increased. The velocity has increased. The velocity of electrons has increased. Just look at this equation. Minus E by M. E is the charge of electron. Capital E is the electric field. That's a constant. M is the mass of electron. It is also a constant. That means this acceleration is a constant. That means this acceleration is a constant. Right? And what will be the velocity of electron? The next velocity or final velocity, the changed velocity of electron. What will be velocity? What will be velocity of electron? What will be velocity of electron? That equation. What is that equation? V is equal to U plus AT. That means one electron will have a velocity V1. The next electron will have a velocity V2. The next electron will have a V3, V4, V5. Each electron will get different velocities. Right? There is only A is constant in it. B initial or U is 0, we know that. And the time interval may be different. What is this time interval? Time interval is the time taken to increase this velocity. When the velocity is increasing, when the electrons is accelerating, it will hit on some ions. It will collide with the positive ions. When the collision happens, the velocity change. You know that when collision happens, momentum change. Momentum change means kinetic energy change means velocity change. So this time is the time interval between the collisions. This time is the time interval between the collisions. You got it? So this is the equation for velocity. What will be the equation of average velocity of all these electrons? You can write it as V average velocity is equal to, there will be an average for this U. There will be an average for this U. Initial velocities has an average, that will be U average plus, is there an average acceleration? Is there an average acceleration? No. Why is that? Acceleration is a constant. So you can simply write A. You can simply write A here. And what about this time? Time may be different for each and every one of the electrons. That means time average will be in the equation. Time average. Now, by definition, what is this average velocity? Average velocity acquired by the electrons is called drift velocity. Right? Average velocity acquired by the electrons is called drift velocity. That means this average velocity is drift velocity. So you can write VD instead of average velocity, drift velocity instead of average velocity. What is average velocity initial? UD. U average, what is that? What is average velocity initial? Initial value of average velocity is what? Average value of initial velocity is 0. If there is no external field, average velocity of electrons is 0. So you can apply that value here. Average velocity, which is when there is no electric field, that is 0. Right? Initial average velocity, that's 0. So plus A. What is A? A is minus EE by M. So you can write it here minus EE by M. What is this? U plus AT. AT. T average. Right? T average. I am writing T average as tau. What is this? Tau. Tau. And now I have an equation for drift velocity. What is the equation for drift velocity? That's minus EE by M tau. What is this? Minus EE by M tau. You don't know what is this tau. I will give you what is this tau. Tau is called relaxation time. Relaxation time. Tau is called relaxation time. It is the average time interval between two successive collisions. There will be collision with this electron with ions and with themselves also. Right? Electrons will collide with electrons as well as electrons will collide with this positive ions also. If the electrons will collide with the collide successfully or successively means one collision after the other. One collision after the other. If the electrons collide, there will be a time interval between the successive collisions. Right? There will be a time interval between successive collisions. Average of this time interval is called relaxation. So what is relaxation time? Average time interval between two successive collisions. One after the other. Collision one after the other. That's successive collisions. So the time interval between two successive collisions is called a relaxation. So I will write what is the relaxation time. What is the relaxation time? What is the relaxation time? Average time interval between two successive collisions. Average time interval between two successive collisions. That's called the relaxation time. Okay, and it has an order. I will give you the order of relaxation time. What is the order of it? The range of the value. The range of the value will be 10 raised to minus 14 seconds. It's that small time. It is a very, very small time. That's why the order looks like this. 10 raised to minus 14 seconds. So that's relaxation time. Average of the time interval between two successive collisions. Right? That's the relaxation time. Now you have equation for drift velocity. This is the equation for drift velocity. Got it? This is the derivation of equation for drift velocity. Complete this. Is it okay now? For Arfat, Gobiga, Joseph, Neha, Riham, Sidra, is the derivation for drift velocity is okay? Okay. Okay, Sidra. If you have completed this page, I will show you the next page. Is it complete? Abid? Yes, sir. Everyone completed this first page? Did you understand the derivation correctly? It's a small derivation, very simple. For your examination, so this chapter will be. How many chapters did you go through? Only 3.
That is not half yearly. It's
Which? May 30. June 2nd. You have 5 chapters in for the exam, right?
This midterm was done. Yeah, so the exam and midterm is done.
Vacation കഴിഞ്ഞിട്ട് ആ വെക്കേഷന്റെ സമയത്ത് നിങ്ങൾ അതാ മൈൻഡിൽ വെച്ച് നടക്കും. അതെ, പക്ഷെ ടൈം കിട്ടും. Is it complete? Okay, Joita? Pasha? Joita. Everyone, Arafat, Gobiga, Joseph, Neha, Reham, Sidra, have you completed the first page? Okay, okay, Reham. Can I move to the next page? Okay, see, this is the rest of the derivation. This is the rest of the derivation. Right? This is the rest of the derivation. There will be a force acting on electron. A force acting on electron. There will be a force acting on electron. That force is F is equal to QE, right? F is equal to QE, and Q is minus E in our case. So F is equal to minus EE, minus EE. Then also we have another equation for F. What is the next equation for F? That's F is equal to MA. Now we have two equations. Both of these equations are the equations of force. So you can equate them. Then MA will be minus EE. MA is equal to minus EE. Q is charge. Right? Q is charge. This is the equation for force. Where do you get this equation? From equation of electric field. What is electric field? That's force acting on charge. Force acting on charge. That's electric field. So from E is equal to F by Q, you can write F is equal to QE. This is the equation for electric force, electrostatic force. Yeah, Q is equal to minus E. What is that? Q is charge. What is the charge we are talking about here? That's the charge of electron. Charge of electron. What is the value of E? Value of E is 1.6 into 10 raised to minus 19 coulomb. If you are writing minus E, then that will be minus 1.6 into 10 raised to minus 19 coulomb. That's charge of an electron. That's negative charge. That's how you can write for E. Q is equal to minus E. Then F is equal to minus EE. And also, we have got this equation for A. A is minus EE by M. Now, velocity of electron has this equation. V is equal to U plus AT. What will be average velocity of electrons? That will be this. All right. One more thing also, velocity, average velocity of electrons. Average velocity of electrons. Average velocity of electrons. V average is equal to U average plus A into T average. What is that T average? That T average is tau. That T average is tau. Tau is relaxation time. What is relaxation time? Average time interval between two successive collisions. That's the relaxation time. Its order is 10 raised to minus 14 seconds. That's a very small value of time. This is the collision time between the collision, right? T1 is what? T1 is time between collisions of first electron. What will be T2? Time between collisions of second electron. What is T3? Time between collisions of third electron. If you are taking the average, that is called tau. If you are taking the average of this time, that's tau. You got it? So tau. This is the equation for drift velocity. Vd is equal to minus Ve by m tau. Okay? Huh? Is the derivation okay? Jovita, is there any problem? Any confusion? Yeah. That's it. Then I will give you the next derivation. There is also another derivation, very simple one. Right? That's called relation between current and drift velocity. What is this? The relation between current and drift velocity. Right? That's what we are going to see now. Relation between current and drift velocity. Current and drift velocity. Let's see what is it. Okay. Look here. I am drawing the same figure here also. I am drawing the same figure here also. This is a conductor, and I am applying a voltage to this conductor. Right? I am applying a voltage to this conductor. If I am applying a voltage to this conductor, the electrons will move in this direction. Right? We have seen that voltage. When voltage is applied, electrons will move in the opposite direction of electricity. You got it? Okay. And I am taking the length of this conductor, that's L, length of this conductor as, how can you find length from the idea of velocity? What is velocity? Displacement by time. That's the general equation for velocity. Displacement by time, right? Displacement by time. That's velocity. What is displacement? What is displacement? That's velocity into time. Velocity into time. That means you can represent displacement as velocity into time. Is that okay? So you can represent this length as, what is this length? This length is this whole length. This whole length is what? This whole length. I will show you a length here. This whole length. What is this whole length? You can write this whole length in terms of velocity. How will be that? The average velocity of electrons are called drift velocity, right? Right? The average velocity of electrons are called drift velocity. So the length can be written as velocity into time, right? So length can be written as velocity. The velocity here is drift velocity. Drift velocity into time. Drift velocity into time. Can you do that? Length can be written as velocity into time. Here, length can be written as drift velocity into time. I mean, drift velocity into time. Is that okay? Okay. Now, what is the equation of current? What is the equation of current? I will write equation of current. What is equation of current? That's V by R, right? V by R. We can write the equation of current as V by R. So V by R is what? V by R is what? Ohm's law. That's the equation from Ohm's law. Another equation is the for current. What is the another equation for current? Current has another equation also. What is that? In the terms of charge. In terms of charge, what was that? Q by T, right? Q by T. If you find this Q, just divide it with T, you will get current. Yes, sir. Are you getting the idea? That's how we are going to find the relation between current and drift velocity. Let's see how is that. Let's see how is that. I am introducing you to a new term here. That new term is N. That's called number density. What is N called? N is called number density. Number density. What is this number density? Number density. It is nothing but number of electrons per unit volume. What is this number density? What is it? Number of electrons. Number of electrons per unit volume. Per unit volume. That's number density. That is called number density. Okay? Hello? Okay. Okay. Okay, number of electrons per unit volume, that's called number density. What will be the equation for N? What will be the equation for N? Number of electrons per unit volume. You can call number of electrons as n. You can call number of electrons as n. Then what will be the equation? Number of electrons per unit volume. How will be that equation? How will be that equation? That equation will be n divided by v. Number of electrons per unit volume, n by v. Then what will be the number of electrons? Now, what is that? N into v. Right? N into v. N into volume. Number density into volume. What is this v? Volume. What is volume? Area into length. That's volume. Area into length. Area into length is volume. So you can write area into length, that's volume. V is equal to area into length. What is length? Yeah, that's area into length is what? BD into T. BD into T. Right? BD into T. BD into T. Is that okay? So you can substitute that here. N is equal to what? N into A into BD into T. This is number of electrons. You have n number of electrons with you.
So, given the delta, maybe
Which is the this one. This one.
No, to the right.
This one.
So right.
Right.
Yeah.
Here.
Yeah.
This is not delta. It's A. A. Volume. This is volume. Volume is area into length, right? Should I write? No. Volume is area into length, right? That's volume. Volume. Okay. So volume is area into length. So area into what is length? You can write VD into T for length. VD into T for length. And this is number of electrons. If you have number of electrons, what will be the charge? What is the relation between number of electrons and charge? What is the relation between number of electrons and charge? How can you find charge if you have number of electrons? Yeah, N. Number of electrons is N and charge on electron is E. Then what is the total charge? That's Ne. Quantization of charge, we have seen that. Quantization of charge. In that way, you can write it as Q is equal to Ne. Okay, so you can find the total charge. Total charge. You can find the equation for total charge. What will be the equation for total charge? What will be the equation of total charge? Q is equal to Ne, right? Ne. Ne. What is that? N is what? N is small n A BD into T. Now just multiply it with E. You have Q now. You have Q now. What will be current? What will be current now? What will be current? I is equal to. What is the relation of current with charge? Charge by time is current. Q by T. Q by T, right? Q by T is current. That means this is Q N A V D into T E. That's current. So the charge divided by time. Divided by time. What will happen now? This T will be gone. T will be gone. That means I has this equation. That N A V D E. A V D E N. A V D E N. That's the equation for current. That is the equation for current. This is the equation that is connecting drift velocity and current. Very simple derivation. Very simple. Okay. Very simple. A V D E N. A V D E N. Current is equal to A V D E N. Current is equal to A V D E N. Please write down the note. Current is equal to A V D. Very simple derivation. Relation between current and drift velocity. The only thing you have to remember is You can write L, that is Vd into T. Velocity into time. This is the figure. And N is what? Number density. What is the number density? Number density is the number of electrons per unit volume. What is that? Number of electrons per unit volume. If you can write number of electrons as capital N and volume as V, what will be the equation? Small n is equal to capital N by V. N by V. So what is this capital N number of electrons? That will be small n into V. What is this V? V is volume. What is V? V is volume. What is volume? Area into length. Volume is equal to area into length. Volume is equal to area into length. Area into length. What is the area? That's A. A into L. Then you can also write it as A into Vd into T, because L is equal to Vd into T. L is equal to Vd into T. So V is equal to VA Vd. You can substitute the value of V here, N into A Vd. Now you have N. What is Q? Q is equal to N times E. So you can substitute for N here. This is N and this is E. And now you have charge. If you have charge, find current. What is current? That will be Q by T. What is current? Q by T. Just write Q by T. The T will be gone from the equation. You will get the value of current. Value of current will be I is equal to N V A V D E N. A V D E N. Okay? Current will be A V D E N. A V D E N. Yeah, the break will be at 5:45. And we have to change the class to room number 4 below. Room number 4. After the break, you have to sit there. Room. Is it complete? Are you finished? Is the derivation okay for you guys? Arfat, Gobiga, Joseph, Neha, Reham, Sidra. Is the derivation okay for you? Okay, Arfat. Okay, Neha. Okay, can we move to the next topic? Not really next topic, the extension of it.
So what's that?
That's something that is going on with the Firosa. You will see that. Can we move?
Can you move?
Yeah, it's a whole thing. It's actually a good thing. Okay, guys. Here, what about current density? What about current density? No, there is no need to write this large heading. Current density. Just need a small subheading. Current density. What is current density? Current density is J, right? Current density is J. So you can write this current density in terms of drift velocity. How will be that? I divided by A is current density. Right? Then what is the equation for I? I is A. No. I is A V D E N. This is the equation for current now in terms of drift velocity. Then what will be the equation for current density? A V D E N divided by A. What will happen now? This A will be gone from the equation. That will leave you with this equation. J is equal to V D E N. So simple one. J is equal to V D E N. J is equal to V D E N. J is equal to V D E N. That's our next equation. J is equal to V D E N. Is it okay? Okay. Now the next one. Expression for electrical resistivity. Expression for resistivity. Expression for resistivity. expression for resistivity. Let's see what is this expression for resistivity. Expression for resistivity. Okay, let's see expression for resistivity. We are starting from the equation of current. What is the equation of current in terms of drift velocity? That's A V D E N. Right? A V D E N. Now we need equation for resistivity. What is the equation for resistivity we already have? Can I read this part? What is the equation of resistivity we already have? Rho is equal to RA by L. That's the equation we have, right? This is in the form of resistance, area, and length. Now we need this equation for resistivity in terms of drift velocity. How can we do that? We have this equation for VD. What is the equation for VD? Minus EE by M tau, right? I am removing this minus. This minus just shows the direction. I'm just using the magnitude only. Then the VD will be EE by M tau, isn't it? That's drift velocity. So drift velocity is this. I have drift velocity in this equation. That's VD. So I can substitute VD from this equation and use this one. That's A into, this is what? EE by M tau. Right? Okay. Now I have another equation for electric field. What is the equation for electric field in terms of voltage? What is the equation for electric field in terms of voltage? What is that equation? What is that equation? What is that equation? Electric field in terms of voltage. What is the relation between electric field and potential? That's minus dV by dr, right? That's minus dV by dr. That's the equation, right? From this equation, you can write E is equal to V by L, right? V by L, potential by distance. That's electric field. Potential by distance is electric field. So, what is electric field? Potential by distance. What is electric field? Potential by distance. What is this V? What is this V? This V is potential or voltage. Potential or voltage. It is not velocity, it is not volume, it is potential. Voltage. Okay? So you have equation for E also, then I is equal to A is there. E is there. Instead of E, you can write V by L. Is that okay? V by L, and M is also on the denominator, right? And the response. Okay. And look at this equation. Look at this equation. There is a V here, right? You can see a V here. You can bring this V to the other side of the equation. What will happen? If you are bringing the V to the other side of the equation, what will be the next step? What will be the next step? That will be I divided by V. That will be I divided by V, right? Then what is left here? A, E, tau by M, L. A, E, tau by M, L. Right? Right? Or I will just use this tau A by M, L. This is like problem, right? There is an E in it, right? There is also a E in it. So there will be a simple problem here. That's VD is E by M tau. So if I am writing for this VD, and there is also E and N is there. We have forgot it. And what is this? Now this E into E is what? E square. So N E square E A divided by M. This is this equation. Okay. Now E is V by L. You can write for E N E square. E is what? V by L. There is A. There is N. Right. And what is this? You can bring this V, just like we discussed before. You can bring this V to the other side. The other side you have I. If you are bringing V to the other side, that will be V by I. What is V by I? N E square A by M L. Right. Right. What is this I by V? We know that V by I is resistance. So what will be I by V? That's 1 by R. I by V is what? I by V is 1 by R. So now this is 1 by R. If you are taking the reciprocal, it will be that. If you are taking V by I, that will be ML divided by N E square A. Right. Now this is V by I. V by I is resistance.